Hello, worldly crazy people out there. My name is Michael. I like wizards and dragons and making games, and welcome back to making games in GameMaker. So we have ourselves a player controller. We can do things with the player, such as move around and run and jump, and basic verbs. We don't have any of the fancier verbs like talking to people or casting spells or anything like that, but we'll get there. We've got basic player verbs. So I believe last time I resolved to start thinking about collision systems, and I thought about putting off recording this video until I had made a little bit more progress with the 3D collisions videos, but then I decided that, you know what, I really want to actually do this because I have time and I like doing this game. So I'm going to get that in the game now. So this isn't quite the final version of the 3D collisions system that I've been making for the past 2 years, but it is pretty close. It's got all the features I need. The only thing that's really missing are a few optimizations that I want to talk about on video later, but we probably won't be making any levels that are going to be huge enough that that's really going to be a dire issue. So let me go and create myself a local package. I can just include the collision stuff folder. I kind of wish you didn't have to fill out like all this metadata every single time you wanted to save a you can just save it over that to save an asset package, but all right. So we've exported what I had in the last version. I don't remember if that was let's see. We can go and drag it into GameMaker, and we can import that asset package. Collision stuff. The wonderfully named folder containing some shapes and some other relevant bits of collision code. Okay. I have way too many repositories in here. When I do finish the 3D collision series, I'll probably update this extension in this project, just so that it does contain any last-minute changes that I make, such as including but not limited to optimizations, but it should be good enough that we can work with it for now. So the way that I'm ultimately going to handle collisions with objects and stuff like that is that in my what are we? This project here, in my my 3D model program. We can reset that transform so that it's not huge. I'm going to be assigning shapes to these objects. So I'm going to say like this treasure chest is going to have like a box, collision box, and this, I don't know, this block is going to have another collision box and that kind of thing. But I'm not going to worry about that now. Right now, while I'm just getting collisions set up, I'm just going to hard code a few things. So we can, in our, and I've said this several times, but this is definitely not going to be final code, but in, let's say, do I have a room start? I'm going to say, I'll go with create for now in obj_game. We can say self.collision world, or just really self.collision is going to be a new call world. The bounds min, bounds max, let's just for the sake of argument, for the time being, make it -1,000. That needs to be a vector 3, doesn't it? New vector 3. And the max recursion depth, we could just make that 3. I've kind of settled on that as my collision hierarchy size of choice. We can do some things such as, I guess, add the player. I'll worry about the player in a minute. I don't know if I'll actually add the player right now, but some of these test objects, let's not worry about the ground for now. The block singular at 200, 200, and your size is like 32 by 32 by 32, right? I think. So we're just going to look at the block singular when we render the world. And man, what was that position? You're going to be located at 200, 0, 200, and I want to say your size is going to be 32 cubed. We can say self.collision.add. We can say either new call ab, or I can use the new call ab from min-max helper function so that I don't have to deal with like the center of the box. That's going to be 200, 0, need vector 3s again, new vector 3, 200, 0, 200. Point max is going to be new vector 3, 232, 32, 232. I am reveling in this hard-codedness right now. And we can give ourselves a player. And in the player's create event, you know what? All this stuff on the side can go away. Really make things easier. In the player's create event, I can, should I call it shape? Should I call it C shape? In the past, I've called like all my collision shapes like C shape or C object or something like that, just so that the C is there so that I know what it's relating to. I'll go with C shape. We can say self.C shape is going to be a new call. I guess I'll make the player a sphere. And the position can be new vector 3. 0, 0, 0, and the radius can be, let's give you a radius of 16. Okay, that's going to be centered like at the player's feet. I'm not going to draw the visible model for now, but it'll be approximately where the player is. It'll be offset a little bit, but as long as that approximately works, that'll be good enough for me. And then how do I add that to the collision world? Or that's not really my question. My question is like, how do I add it and then move it later? Okay, so it's just like reposition the shape and then update it. Okay. So we can also say, actually, I'm not going to add it to the collision world. I think I said that already. My concentration is a little bit out of it right now. However, in, for example, the step event, I guess we can do some extremely basic if obj game.check object. Oh, you know what I need? I do need to turn the collision shape into a collision object. Self.c object is going to be a new call. Where are we? Object. Like, I didn't think it had been long enough since the last time I worked with this system that I've started to forget like how it works, but apparently I am. C shape. The reference is going to be self.id. The mask is going to be, let's just make that 1 for now, and the group is, just make that 1 for now. I'll probably assign some different masks to different objects eventually. Anyway, I'm also going to need to do the same with the block object, aren't I? Block shape equals that. We're going to add... I'm going to need to save that. No, I'm not, because the block isn't going to move. The shape is going to be the block shape. The reference is really going to be undefined. Who cares about that? And then the masking group can stay 1 and 1. And then we can add the block object, and not the shape itself, right? We add objects to the collision world, and the shapes are just the templates. Okay, I hope I got that right. That'll be very silly if I got my own collision system wrong. All right, so in begin step, where was I? We can say objgame.checkObject self.cObject. I am going to not do this like instantly, but I can say cObject.shape.position. Now that I'm like looking at this, it might be a good idea to have a dedicated like set position method for these shapes, just in case like you need anything else to happen, because, you know, object-oriented programming and all. For now, we'll say self.position is going to be new vector 3, self.x plus dx times the speed, self.y, self.z. And then we can, all right, if not check object, we can say self.x equals dx times speed. And then we can also do these checks on the y and the z axis. So let me just do that here. For the sake of having a little bit more granularity in collision detection, I will that is the z-axis plus dz times speed. And I will pay attention to performance, but anyway, I'll probably do like a while loop over the like the change in the x, change in the y, that sort of thing. I'll probably look at the example collision world test project for that. Anyway, let's see if this works as intended. We shouldn't sync through the floor because I am still... Screw you, game. We shouldn't sync through the floor because I am still, like, hard coding the floor to be y equals 0. But everything else... obj game.checkObject, this is very silly. Can I get this to not crash on start on the third try? All right, great. So if I run into you, awesome. We have a collision. As I said, it's a little bit offset. I can't tell exactly in which direction. That was interesting. But we do indeed have some form of collisions. All right, so we're not like falling neatly because I'm not, when I'm sitting on the block, I'm not like on the ground, and that's not like triggering gravity to stop kicking in or whatever. Oh, actually, that's not happening at all. But we can call that a start. All right, so I think, before I make any changes that I might regret, let me just open up the 3D collision test world real quick and see exactly 3D collisions. I have too many projects. Where's the test world? See exactly how I am like doing that with this here demo. Okay, so in that demo I was basically just doing this. So let's do a few things. For visualization purposes, I just threw together like a vaguely capsule-shaped thing for the player. I also gave it a little nose in the front so that I can tell which side is the front. I think that the rotation for the visible like model is working correctly, but I just want to make sure. I'm going to load this into the game. I'm going to draw it in place of the player, and we're going to have the player's C shape be a new call. I think call capsule, with a start being, let's say, it has a radius of 12, so I'm going to say it's going to go from 0, 12, 0 to new vector 3, 0, 20, 0, and it's going to have a radius of 12, and you do no longer have a single position, do you? So this is going to have to be, yeah, it's going to be .line.start and finish, right? Okay, it's going to be .line.start and finish. See object.shape. I definitely need a nicer way to like reposition a shape. Like, that's not even a question right now. Oh boy, I'm going to, it's a good thing I'm doing this and figuring out like where the sticking points are when you're actually using this. I believe that is affectionately called dog fooding or dog feeding or something like that. When it comes to like, oh god, performance is already leaving a lot to be desired. That can't be right. All right, for one, hang on. It is not possible that checking a single capsule against a single box is tanking performance that badly, is it? Like, if I have to, I'll just use a sphere. We'll break out the debugger, but first, let me say, bring up the draw event. Obj game dot player, no, meshes dot player dot render. Because we were getting like 10 frames per second here. All right, so my rotation is actually off by about 90 degrees. I am colliding with the box. Are you 64 by 64 and not 32 by 32? No, the player's 32 tall. Why are we're colliding? This function has to work, right? Because it's depended on by a bunch of other things in this project that works. Let's say do this the hard way. New call ab. Our position can be our half extents can be and that's it, right? Very, very interested to know why all these capsule collisions are taking the frame rate so. But anyway, if we run over to the center, yeah, see, it looks like I can slowly push myself into the box. All right, so that's just some like collision resolution that I'll have to do. Very strange. What happens if I jump on top of it? Anyway, how heavy is capsule ab? This shouldn't be... Like, this isn't immensely efficient. And there are definitely ways this could be sped up, but it shouldn't be that terrible. Like, alright, so we're checking a sphere versus the ab. We're checking another sphere versus the ab. We're getting the edges, and there are going to be 12 edges in an ab. We're going to take the nearest connection to the line. We're going to take the nearest point, get the distance to, and then check check a third sphere against the ab. Like, that's definitely more than, you know, some things like point versus capsule or sphere versus capsule, but it's also not nothing. But it's also not, like, that much to be doing that 3 times. Well, let me run this in the debugger, break out the profiler, and I can just have a look at it. Let's see. Can I Alt-Tab out of this? Alright, anyway, I should probably add in, or re-add in a way to disable mouse lock. Where is, if I click in the debugger, where's the profiler? Down at the bottom there. And we can have a look. Widget player, step 1 is taking 58 milliseconds. I guess it is that heavy. That's kind of impressive. Okay. If I go bottom up and I look at the number of calls to call capsule, check capsule. Oh, you know what? Because you know what? It's not just checking... Oh, wow. Okay. It's not just checking the capsule against all of those, against the single block. It's also checking the capsule against the quad tree, the octree, against all the abs of the octree. Alright, that's definitely a lot. So I can think of a very easy way to cut down on some of the heavy math that would be involved in this operation, and that is, I can kill that now. Basically, in call capsule check ab, first do a check against like a sphere that encompasses the capsule, and if no collision is detected there, then you can just bail early. And if there is a collision between the ab and the all-encompassing sphere, then you know that there's at least a chance and that it may be worth delving deeper. But I'm gonna have to write that down for the optimization video, aren't I? I've written down a couple individual optimization strategies, but if we say this on average took 54 milliseconds per step for 86 calls. 54 divided by 86. It's about a little more than half a millisecond per collision detection, which is definitely not nothing. That's definitely still more than I want it to be, but I shouldn't have to do quite that many. I think for the purposes of this game, I will just have the player be a sphere with that in mind. Okay. Let me change the player to a sphere, which is what the player was originally. And let me change these collision detection routines back. And fortunately, I can just Control Z a bunch of times, and we can go back to treating the player as a sphere. I will, however, say the sphere's position is going to be like halfway up our bodies, though. Because we don't want a sphere centered at the player's feet, we want a sphere centered at the player's middle. Not sure if the player itself is going to be... I'm not running in the debugger, am I? I'm not sure if the player itself is going to be like of that size. I might make the player a little taller, but we'll probably be a sphere. Alright, so I can now Alt-tab out. I can bring back the debugger, and I can start profiling, and we can look at how long exactly it takes us to run the player's step events. So that's a lot better. In the Collision World demo, I think the player, like the duck example, was also a sphere. And against like 1,000 trees, it worked pretty well. Again, there's still things that could be improved, but it's about 50 times faster, I think, than we were getting earlier. It's pretty nice. Let's see, I think I'm done with that. What I care about now is making sure that we don't... Yeah, see? I feel like there's something wrong with my logic. The collision detection code itself is doing what it's supposed to, but... Okay, so after a lot of screwing around, what the test world is actually doing, and I don't expect this to make a difference, but it may be worth doing for other reasons later, so I might as well try it. But instead of saying if there is not a collision with the object move, what it is instead saying is if there is a collision at this location, dx is going to be equal to 0, so we're going to stop moving. I wouldn't expect that to make a logical difference here, but I'll play along with it. And we will like set our temporary x, our temporary y, our temporary z, and then like update our positions at the end. And if this works, I'm just gonna super not question it, but we'll see. So I can still do that. Wow. Okay. I'm sure if I stepped through it line by line, like on a sheet of loose leaf paper or something, I could figure out why it was doing that. But instead, I got to sit there for a half hour trying to do it in real time on the computer, and yeah, hooray. Okay, not gonna question that. But anyway, we've got like basic movement. I definitely want a nicer system for going like interoperating between the actual game objects and the collision objects. I feel like I'm gonna want every game object to have like a test potential movement method or something like that, and that'll take the XYZ for your potential movement, and it'll return an XYZ for what you're actually allowed to do based on the collision system. I might save that for next time. In this video, I'm gonna check off player collision with basic shapes. And am I feeling ambitious? I'll do jumping. I'll do that with the floor jumping. And if I'm really feeling ambitious, I'll do climbing. Okay. So let me check off this. We'll do collisions with the floor and that sort of thing, and then maybe we'll do climbing. And then I will add another card for a... I'm a little surprised I don't have a card for this already, but, alright. I'll give that 5 points of work, because one, I feel like the other collision-related tasks in this hand are a little bit undersold for how much work they're going to be, honestly. And two, I do expect that to have a lot of parts in the game that are going to need to be rewritten. But for the time being, all right, that was quite a commit. And also, because I'm apparently still drawing the player facing the wrong way, how do I want to deal with that? So we have the player, and you're using Z as the forward axis. And if I were to just like set the players, I can rotate you 90 degrees around the Y, 270 around the Y. If I make X your forward axis, I thought to re-export those. I thought Z was my forward axis, but apparently not. But okay, that should I'll have to like write that down somewhere to make sure that I don't ever, you know, mess that up. Did he do it like that for like Unity reasons? I might have to fiddle with the coordinate system a little more again for Unity reasons. But wow, we really jump, and I'm gonna do jumping next. Okay, if you can call that player visuals. So one, when you jump, you really rocket off into the air. And I really don't want the player to rocket off into the air that hard. Again, alright, that's not nearly long enough. I might play with player like jump curves later to make it feel good. Or at least better than this, but we don't want crazy insane rocket jumps. Alright, so that's great. Next, to deal with gravity, I'm gonna add a method that says self.is grounded. And to do this, we're going to subtract a small amount from, maybe not quite that small, but I'm going to subtract a small amount from the player's Y position. I'm going to say var grounded is going to be obj game dot collision dot check object, and object is going to be self dot see object. We're going to undo transformation on the shape's vertical coordinate, and then we're just going to return the result. So we're basically going to see if there's a collision just under our feet. And the purpose of that will be, we can say if grounded, so if we're on the ground, we can just say that, let's see, if we're on our way down, then we'll stop moving. We can also achieve this in a slightly, perhaps more concise manner by saying self.y speed is going to be equal to the max of 0 and self.y speed, but I feel like for readability purposes it's better to use the if statement here. Thinking about this, okay, dy is still going to want to be player y speed, and that's like another one of the things that will definitely be cleaned up later on when I get more entities and flush out the entity hierarchy and like interop whatever between you know, the player and the objects and the collision system. I'm also going to want to say have a check for the ground, like if you're actually on the ground, because then we're still hard coding the ground for now. I'll add a plane later, maybe. Let's see, what else was I thinking? Debugging. Let me just make sure that's like actually running when I think it is and returning what I think it is. All right, we're on the ground. We're not on the ground. Interesting. Okay, I have a feeling I know why that is. Again. All right, let's test this hypothesis. Let's make something like 1 our test distance. I've still yet to find like a perfectly elegant solution to this. Alright, so clearly that's not working either. Let's make it like 5. I've still yet to find a perfectly elegant solution to 3D collisions. I found a lot of solutions that are good enough, but have some funny edge cases. Alright, so it does realize I'm grounded when I'm standing on this, so that basically confirms my hypothesis, which is that I'm not moving perfectly to contact the surface below me. And now when I exit the barrel, when I exit the block, I actually like fall nicely instead of just snapping to the floor. Okay, that's good to know. Solution to that, I think, is going to be to do a little work on the movement here to make movement a little smoother. I don't have a perfect way in this collision system to like push objects that are in collision with each other out along like the normal of the collision surface until they are exactly like sitting flush against the surface. That is really more of a physics resolution thing, which I'm not interested in implementing right now. The alternative is to actually do something that some people might dread a little bit, and do this in a loop. And instead of simply doing a single check here, we can say loop over the magnitude of dx, dy, dz. If you find a collision, we can say dx is going to be I minus 1, because we want to set our movement amount to the previous iteration. And then break out of the loop, and we can do this on the other axes of motion as well. And this does kind of sort of turn into a lot of collision checks. And given the little catastrophe that I just had with capsule collisions, I'm going to want to be a little careful with that. This isn't too much of a worry in regular GameMaker collisions, because regular GameMaker collisions are a lot faster than mine.
Hey.
Both because they're simpler, because they're not working in 3 dimensions, and because they're implemented in native code. But we'll profile this, see how it works, see how it performs. Like, it's not immediately lagging the game, which is good. We are still probably... Alright, that one hit me full in the face after about 30 seconds. We're only iterating in a positive direction, so I want to say I is less than the sine of dx, I++. When we test our potential position, I'm going to say self.x plus I times the sine of dx, and dx is the final dx is going to be I minus 1 times the sine of dx, and same thing on the y. And same thing on the z. This confused me a moment because it looked a lot at first like the same error as I was having earlier, where I was unable to collide with like the Z axis. But the source of this is a little bit different, and that's because we're only iterating in a positive direction, and our movement can be in a negative direction. So if you're going backwards in either direction, then you're a little out of luck. Okay, I'm bouncing off it now. Did I mess up X? Sine dx, sine dx, sine dx. The other Z was fine. Oh, abs. That needs to be abs. Alright. Yeah, that threw me through a loop for a minute, because that looked very similar to the problem that we had colliding with, we're still getting a little jitter around the edges there. That looked very similar to the problem that we had with, like not being able to detect collision on the Z-axis, earlier in the video, but the cause was slightly different. So now, I can fall off, so we're correctly detecting if we're grounded or not. This is more or less what I want. And I did say that I would profile that, so I want to say originally the collision detection was only taking like, let me move closer to the box so that there's more interesting things happening here before I tab out. We were taking up a whole millisecond in the player step event because of this. Am I really not taking any longer than that? Huh. I mean, right now I'm not actually moving. Okay, so I had a bit of another brain fart when I was testing that earlier, in that most of the sphere collision checks aren't actually going to run unless the player is actually moving, which I wasn't. So let me run in circles around this for a few seconds, and then I'll just kill the game. And like maybe if I jump up and down and check for collisions on the vertical too, we can really put the collision system through its paces. That should be enough. Okay. So that's more or less what I expected. This isn't ideal, since we are iterating a bunch of times on the over these loops, over like dx, dy, dz. And of course, if you have like, say, 10 enemies on screen, and if they're all pathfinding, and if they all take an average of 2 milliseconds a piece, that's not really going to be ideal. This also comes with a drawback that we're now moving in like integer positions and like integer increments. I can slightly cut down on the number of iterations I have to do by setting that to... Can I get away with setting that to 0? Setting this to 1? Yeah. Because obviously you're not going to detect a collision with anything if you move on an axis if you move 0 on that axis. To account for the floating point, to account for the rest of the floating point position, you could do an additional collision check like at the end. All right, so this is going to be like a basically a break-even point. First, let me separate var final dx equals 0, final dy equals 0, final dz equals 0. And then instead of saying reassigning dx, dy, dz, you can set final dx, dy, dz, and then we can move by final dx, dy, dz. And if, say, there's a fractional amount left over, so if... Oh, you know what? Wait, if I do one more... I have an idea, I have an idea. If there is no collision check... Man, how am I going to do this? If there is no collision check, plus dx like over the total distance. So if you're clear to move over the total distance. So if there's nothing between you and your destination on the x-axis, then you can just say final dx equals dx, and you don't really have to iterate over it. And if there is something colliding in between there, that's when you can do the loop, and that will, one, allow you to move that like final fractional amount, and you'll only be like snapped to an integer position if there's something in the way, and two, it will mean that you don't have to do this entire loop if you're in the clear. Is that one of Sean Spaulding's collision like while loop tricks? I don't remember. I'm actually not like expertly familiar with Sean's collision code, despite making that one funny joke about it a while ago, because I so rarely make platformer kind of games, and I often employ other tricks in collision detection. That means that I don't use like the classic repeat until you hit something collision code. This is getting very ugly very fast. This will probably be the last thing I do today. I'm not going to do climbing today. I think that ship has sailed a long time ago, with regards to how long this video is going. Alright, all my variables are up to date. Let me run this in the profiler again. I will do my same exercise as before, where I've run in circles and jump over the block a few times. And hopefully we get noticeably better than 2.3 milliseconds per step for the player. Alright, so when I like jump forward next to the block, oh, I can, alright. I was thinking, for some reason it looked like I was getting, alright, if I'm on the corner and if I jump into the block, I like get stuck. I'll have to think about that. That might be worth, Alright, so we've reduced the amount of time it takes to compute that by like 25%. That's pretty good. I might list that on the bug board in Codecks, which is that the player gets stuck if they try to jump against a wall. And like it shouldn't do that, because the player should just go like straight up in the air when it checks on the vertical axis. And it wasn't doing it when you were just against the wall. It was specifically in the corner. Definitely a tomorrow problem. Okay. That was an ordeal. Who knows? Maybe like enemies will have cheaper collision detection because they don't, like, the player isn't going to be looking at them the whole game, and it doesn't, if they cheat a little bit on the collisions, it can be more, a little lax. There are other optimizations I can do to make this work. Some of these functions can be inlined, for example, that kind of thing, and then I'll definitely look into the profiler with specific collision checks to see what's more expensive. But that's going to do it for me for today. That took a lot longer than I wanted it to. Week 11. We finally have collisions. Did not get climbing, did I? Yeah. It definitely took longer than I thought. Next time, I'm going to try to make the interface between entity collisions and the collision objects a little nicer, so that you don't have to do this whole big nonsense thing, anytime you want to implement collisions. I talked about a, get potential movement based on the initial dx, dy, dz, and it's probably going to look something like that. And I definitely do want to get to climbing, because climbing, I think, is going to be fun. It's going to be a little hard to visualize when our player is just, a capsule, but I think it's going to be fun. Until then, my name is Michael. I like wizards and dragons and making games. If you want the code for this, look for the GitHub repository down in the description of this video. Look for the 0.11 release I just made. 0.11, week 11. Otherwise, I try to post about 2 game dev videos a week. One, let's make a game like this, and one tutorial, generally dealing with the weirder things you can do in GameMaker. I hope you all find this interesting, and I will see you all later. Special thanks to Zenjamin, VitroV, Squarecrow, Syndra Larson, Rowdy Coder, Manta Ray, Harold Guidry, GameMaker, Edward Holt, DJ Gibbles, and Army Armbuster for supporting these videos. If you want to support the channel, head on over to the Patreon page down in the video description to join the fun.